Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to Grade 9 Elite Math Term 1. Today we are covering from Integrated to Module 6 Measurement, lesson number 2, which is Area of Regular Polygons. This video is part 1 of the session, and today's learning objective would be to find areas of regular polygons. So let's look at some regular polygons. If all sides of a polygon are equal, it is a regular polygon. So if it is all three sides equal, it's a triangle. All four sides equal, it's a quadrilateral, which is a square. All five sides equal, it is a regular pentagon. All six sides equal, regular hexagon, and so on. So on this slide, you can see different kinds of regular polygons. And in today's session, we are covering part 1. Our learning objective is to find the area of regular polygon. So let's look at the different parts of a regular polygon. Here you see a regular pentagon. AB, BC, CD, DE, and AE are all equal. So how you can mark them? Using this kind of a red marking to show that all are equal, and that's why it's a regular pentagon, five-sided figure. So five sides, and it is inscribed, it is inside a circle with center P. So you have this big circle which is surrounding the vertices of the regular pentagon, and it is having center P. So this P is also the center of the pentagon. So the center P is circumscribed about the pentagon, or the center of the circle, which is point P. So this is one part of the regular pentagon. All sides are equal, and now we'll get to know some more terms. Next part is epithem. What is this epithem? Let's understand. So in the figure where you have the regular pentagon, I'm using the same figure with center P. Center P is circumscribed about the pentagon, we have already discussed. So epithem is what? For a regular polygon, it's a perpendicular segment. So 90 degrees is going to come, as you can see, from the center to the center of the side. So AB, any side you take, for example AB, all sides are equal, you know that. So the center of that side AB is point F, and if you join point P with point F such that PF is perpendicular to AB, that means this angle is 90, then PF becomes the epithem. So in this example, the epithem is PF such that, what is the condition? PF is perpendicular to AB. The angle is 90. So it is a perpendicular segment joining the center of the polygon to the center of the side of the polygon. Next important point is the central angle of a regular polygon, and it is, as the name suggests, the angle which is at the center. So center is point P, so this angle APB. So any side you take again and you join the two ends of the side with the center, what you get is the central angle. So it is joining, it has the vertices at the center of the polygon and the sides that pass through consecutive vertices of the polygon. Consecutive means one after the other. So A and B are consecutive vertices of the polygon. You join them with the center. So angle APB. This angle is the central angle for this regular pentagon ABCD. Now there's a formula, this is important, that you will use to measure the value of the central angle. So if the polygon is having n equal side, it's n regular polygon. So n is 5 here because it's a 5-sided polygon. So each measure of the angle would be 360 degree divided by 5. So now you can do this calculation. I want you to think and tell me what is the central angle for this regular pentagon. So 360 divided by 5, what you get is 72 degrees. So this angle would come out to be 72 degree, which is angle APB, or the central angle. Similarly, you can find the central angle for a hexagon, for a heptagon, and so on. So let's solve a question together. Here in this question, you are given a regular hexagon. You can see let's mark the equal sides: JK, KL, LM, MN, PN, and PJ. All are equal and they are inscribed in a circle with center at R, this point R. Now you need to identify the center, so that we have already done. The center is the point R. Identification is done. Then the radius, there are so many radius, but anyone you can say. So center to a point, so RK or RL, both are equal, they can be center. Then epithem, so by definition of epithem, it is joining the center and the side center which is perpendicular. So epithem is RS because it is joining center to this 90-degree point on the side. Then central angle of the polygon. Central angle joins the center with the two vertices. So KRL. KRL. Now to find its measure, we need to use the formula 360 degree divided by n. This is going to give the measure. N is the number of equal sides. So 1, 2, 3, 4, 5, 6. So divide 360 by 6 because it's a hexagon. So 60 degree is the measure of the central angle. I hope you've understood this question, and now I want you to try one question yourself. So in this question, you are given a regular square FGHKJ. So all these sides are equal. It's a regular figure because all sides of a square are equal. Center is given. So identify the center. Center is point K. Identify the radius. Radius can be any point, KJ or KH, both are equal. Then epithem. Epithem is also very easy here. Epithem is perpendicular, so joining center to L, so KL, and it is given KL is perpendicular to KH because this angle is given to you 90. Now central angle. Central angle would be GKH. Angle GKH. Now the measure of angle, central angle, how you will get 360 degree divided by n. N is how much here? There are 4 sides, so we'll divide by 4. So each measure is 90 degree, and that you already know. That being a square, each angle is 90, and here also this angle when you divide by 4 would come out to be 90. So this is the measure of the central angle. That completes the question. Now that you know how to identify the center, the radius, the epithem, the central angle, let's now find the area of a regular polygon. So the formula is given here on the screen. The area of a regular polygon is given by the formula 1 by 2 times perimeter times epithem. So epithem you can easily find using trigonometry, using the right triangle, and once you find that using Pythagoras theorem, you will be able to get your value of epithem. And then perimeter you can always find because all sides are equal. So if only one length is given, you can multiply it with n to get your perimeter. So let's solve a problem now to see how to find area of regular polygon. Just learn and remember this formula. We'll be using it to solve questions now. Let's now solve a problem on area of regular polygon. So here the word problem is Lindsay created a patch for the robotics club at her school. The patch is a regular octagon. Octagon means n is 8. Each side length is given to be 4 centimeters. So all sides are equal. So this is 4, this is 4, all sides are 4. Let's mark the equal sides. And there are 8 sides which are equal. Find the area covered by the patch and round to the nearest tenth. So area covered by the patch would be the area of this regular pentagon, regular octagon. So 1 by 2 perimeter times length of epithem. So if we are able to find epithem, we are done because perimeter is 8 times 4 centimeters. So perimeter is 32 centimeters. We just need the epithem. So let's do the steps in the next slide. Okay, so in order to find our epithem, we are first going to find the central angle because we'll use some trigonometry to do that. So the angle ABC, which is central angle, is 360 degree divided by 8. So this comes out to be 45 degrees. So this whole angle is 45 degree. Now let's draw only the right triangle. that we need. So this is epithem which we want. This is point P, this is point A, this is radius. This one now AC, total length is 4 centimeters. So this divides into two parts. So this will be 2 centimeter. This is the midpoint D, A, this. Now how much will be this angle? It will be the half of the total angle. So it will be 22.5 degrees. So now in this right triangle, you need the epithem, which is the adjacent. Opposite is given to you, so opposite over adjacent is tan. So tan 45 divided by 2, which is tan 22.5, is equal to, if you remember trigonometry, so cut over is equal to opposite over adjacent. So opposite is 2, adjacent is 1. Now use your calculator. Tan 22.5 is 0.4142 is equal to 2 divided by A. So your epithem will be 2 divided by this, which is equal to 4.828. Let's round it off to one decimal place. So we'll take 4.8 centimeter. So length of epithem is near about 4.8 centimeter. Now we use this formula. Perimeter already we have got 8 times 4, which is 32. Just plug in this formula. So area is 1 by 2, 32 times the epithem, and unit will be centimeter square. So this is near about 77.29 centimeter square, which is near about, because we need to round off to one decimal place, 77.3 centimeter square. So that's the area of the regular polygon. I hope the steps are clear for you, and please try out more questions on area of regular polygon. The exit sheet of today's session would be this question that I want you to try yourself. So here a pentagon is given. So n is 5. 1, 2, 3, 4, 5. All 5 sides are equal. You have to identify the center point. So it is point P. Let's fill it here. Radius, it can be PR, which is equal to PQ, anyone. Epithem would be PS. Now you need to find central angle. So central angle would be RPQ. RPQ, and its measure would be 360 degree over n. Now it's a pentagon, so n is going to be 5, and when you divide 360 degree by 5, this comes out to be 72 degrees. So central angle of a regular pentagon is 72 degrees. That completes the question. So that is all in today's session. That completes Module 6, Lesson 2, Area of Regular Polygons, Part 1. Coming up next on my channel is Part 2 of the series. So make sure you subscribe to the channel and press the bell icon so that you don't miss the upcoming video. If you liked watching the video and found it useful, do like the video, share it with your friends who will also benefit from it. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.